I'm Lee Duke, and today I want to speak with you about ground fault interrupters. Now, I've been doing electrical work for over 25 years. I've held my unrestricted electrical license in the state of Georgia. I've been working in maintenance, so I've been around it doing electrical work for well over 25 years. And I've installed these many, many times. So I'm going to talk to you about the installation and the operation of a ground fault receptacle. First of all, anytime that you work on electricity, make sure you check, make sure it's off, make sure it's not energized so that you don't get electrocuted. We don't want anybody getting electrocuted. So always check it, always turn it off. Don't work on an energized circuit. And you can use a meter like this. It don't have to be this particular one, but this is the one I use. And every meter will have two leads you can check. So before you do anything, you can check, put one in one side, one in the other. Make sure your meter is on alternating current. That'll be the wavy line here at the bottom, V. That's for alternating current. Once you verify that the circuit is off, you can go ahead and take these screws and pull it out of your box. Your box may look like something like this, mounted flush in with the wall. And so it may be sitting like this when you get there. So pull it out, the wires will be connected to it. Now, you can have more than one circuit going to it, but we're going to deal with the one circuit. Typical house wiring, you're going to have three wires. You're going to have a neutral, which is white. You're going to have a ground, which is a bare copper wire. It doesn't have any insulation on it. And then you'll have the black wire. Now, the black wire usually is the hot wire. It's the one that's going to be energized. But just remember, electricity doesn't care what color the wire is. So always be careful and check. So the neutral will be white, the hot wire will be the black one, and the ground will be the bare copper. And you notice I got a hook in this one, and this one, and this one straight. I'll show you the reason behind that. The ground needs to have the hook. These are optional. You can do it either way. And I always do the ground first. And the ground will go to the green screw. And we're going to hook it from left to right in a clockwise fashion so that when it goes in, it's turning in the same direction that you'll turn your screw to tighten it. That way it doesn't twist off. Okay? Once you tighten your screw down, then we'll move to the black one. Now, the black goes to the gold colored screw. There's a gold colored screw here. There's a silver screw here. The white wire, the neutral, will go to the silver screw. The hot wire or the black wire will go to the gold colored screw. It's very important. If you get them mixed up, it won't be right. Now this one's straight. We have holes back here that you can stick it in and tighten it down, or you can hook it and wrap it around the screw. It really doesn't matter. I personally usually wrap it around, but it's just because I'm old school. But both serve the same function. And then once you put it in there, you tighten it down. Always give it a tug. Make sure it's in good. And I will attempt to do this one. Sometimes it can be quite aggravating. But you want to go clockwise again, just like you did on the ground. Like so. And then tighten it down. Now, once you get this together, this is your power cable coming in. It's got a hot wire, a neutral, and a ground. Now what this outlet will do, it will monitor the current between the black wire, the hot wire, and your neutral. And when there's a difference in it, it'll trip out and de-energize anything you've got plugged in here. So if you drop a curling iron in a sink full of water, it's going to drop out. That's the purpose of a GFI outlet. So you have more screws here that are taped. In this particular application, you won't need them. But say you had another outlet in your bathroom that you wanted protected, but you didn't want to change it. Well, you could hook it onto here, and if this tripped out, the other outlet would trip out. And if that outlet tripped out, then it would be protected. So you can protect more than one receptacle by doing that. It's kind of a cheap way to get by not buying many, but the price has come down in the last few years. But once you get that, you can put it back in your box. And just a note, I still see these put in different ways. And I'm not saying anybody's wrong or right, but it's always a good idea to follow code. And the code says if you put it like this, that's correct, with the ground up. Now, this is how we normally see them, with the ground down. This looks normal to us, but the code wants us to do this. And the reason that is because if you have a paper clip or some piece of metal and your plug is partially plugged in and it falls, it'll hit the ground first, and no matter which side it goes after that, it'll short out because you've got your ground hooked up. Now, this way, if it happened and fell across these two, then it could very easily short this out between your neutral and your hot, possibly causing a fire. But that's the purpose. That's why they're wanting it like this. I know it looks odd, but that's the right way to do it. And also be aware that a ground fault receptacle is good and it's needed anytime you're around water, anywhere in the bathroom, around your kitchen counters, in your kitchen, and outside, in your garage, front or back porch, around your pool. Anywhere there's water, it needs to be a ground fault receptacle. But you may run into a case where a ground fault receptacle doesn't work very well on certain pieces of equipment, like your refrigerator doesn't take one. So there's things that may not work very well on the ground fault receptacle, but it's better to have the receptacle and find an alternative power source for something that you need to run. And again, be safe and good luck.